Click the bell icon to get latest videos from Ekeeda.
Hi guys, today we will learn about to solve the numerical which is based on common drain amplifier which is of FET amplifier. Let's see how to solve this numerical to find out voltage gain, input impedance and output impedance to finding. Source is connected to output voltage through capacitor. So I'm getting output at source side. Here coupling capacitor CC2. Output resistance in the form of RS, I'm taking it as 820 ohm. And this DC supply, I'm applying it as -2 volts. Okay. This is very high input impedance. Input side is connected to gate side through coupling capacitor CC1 and this is connected to ground, that is gate resistor. So this is how your circuit for CD amplifier numerical of AC analysis. This is just a circuit diagram. Now let's see what they have given. Given values are one is IDSS which is equal to 6 milliampere, VP that is pinch off voltage which is nothing but -3 volts, and to find out they ask us to find voltage gain, input impedance, output impedance. And one more thing, they have mentioned that if small RD which is equal to 50 kilo ohm, you have to write the effect of small RD. If we are applying small RD is equal to 50 kilo ohm, what will be its effect? So this is all the finding and given all about the numerical number 4. Let's see how to solve it. First of all, in step number 1, we will start with DC analysis. This is because for voltage gain, we require the value of transconductance, and which is not given. Transconductance GM, right? Now GM is directly depends on the value of VGS, right? And VGS is also not given, which is depends on the value of ID, right? And this ID we can get from DC analysis, and that is why we are going for DC analysis first before starting with AC analysis. So step number 1 will be your DC analysis and step number 2 will be of AC analysis. In DC analysis, we have to take care that we have to keep open all coupling capacitors. So input and output has nothing to do with this circuit. So I am applying only DC voltage such that I'll measure DC current in the form of IDQ, VGSQ and VDSQ. Though VDSQ is not required, we are not going to calculate that VDSQ, but it's one of the DC parameter. We'll draw this circuit again. We require only this much part, and that is why we are not wasting this page over here. This is RS and this is connected to -2 volts, connected to ground. This is your value of VGS. If you apply input KVL, this is your input loop, value of RG. If you apply input KVL, then we will be getting, what's the value of VGS? VGS is equal to minus of ID into RS minus of minus 2 volts. Okay, so we will be getting the value of minus ID into RS is 820 ohm, minus of minus will become plus 2. So this is the value of VGS. We will keep this value as it is in equation number 1. We will make use of Schottky's equation, which is given by we'll keep this is equation number 2. I know that IDSS is given 6 milliampere, VP is given minus 3 volts, and VGS we will be getting from this equation, which is nothing but the function of ID, right? So everything I will be getting in the form of ID. We will be getting the quadratic equation in the form of degree 2. So we will be getting root in the form of ID1 and ID2. We have to select one of these two, ID1 and ID2. I'll put first the value of VGS, IDSS and VP. VGS is minus of 820 multiplied by ID plus 2 divided by minus 3 the whole square. Hereafter only mathematical part is left. So what you will do, pause your screen for 2 minutes and solve this up to getting 2 roots of this quadratic equation. So this is your quadratic equation, and check your calc is working or not to find out all the roots of this quadratic equation. I hope you have got same answer as I have got here. 11.05 milliampere, that is ID1, and 3.36 milliampere, that is ID2, out of which I will select this. I will not select this because ID should be less than IDSS, and which is equal to 6 milliampere, which is given. So this value is correct. I will take this as value of ID. I will put the value of ID in equation number 1 such that I will be getting the value of VGS, and then I will proceed further. VGS will become minus 0.755 volts. Now this VGS ka value I will put it in equation of GM, that is transconductance, such that we will proceed further for AC analysis. This is the equation of transconductance, whereas this part is called as GMO, that is offset transconductance. We'll just put the values. 6 milliampere, Vp is minus 3 volts, VGS is minus 0.755 volts, Vp is minus 3 volts. All values clubbed together to get the value of GM. Let's calculate it and then come to me. So the value of GM is 2.993 milli, what's the unit? Siemens or mho. Exactly ulta of that of ohm, because it is conductance type. This is the value of GM we have got. Okay, we'll keep this equation number 4. Okay, now we will proceed further for actual findings, that is voltage gain, input impedance and output impedance. For AC analysis, you have to keep this in mind that we have to short all the capacitors. And one more thing, you have to short all the DC sources. Okay, now my circuit will become. This was connected initially to minus 2 volts. I will connect it to ground directly. Here we are having one gate resistance. Capacitor short circuited, so input is connected to gate directly and output is connected to source directly. Okay, this is your common drain. This is circuit diagram which is required for AC analysis by shorting all coupling capacitors and DC sources. Let's proceed further to go for AC equivalent circuit such that we can get all the findings. Let's proceed further for AC analysis equivalent model such that we can get all the findings. Let's proceed further to get all the AC analysis findings with AC equivalent model. Keep this in mind that here in the given values, RD is equal to 50 kilo ohm, which is given. It's not an infinity. So you have to draw RD, that is dynamic output resistance. This is GM-VGS, which is from drain to source. Here it is open circuit. In between, voltage VGS. Source is connected to output, so this is your output. Here I am having one resistance and drain is shorted, connected to ground directly. Gate is connected to gate resistance, that is RG, and then connected to ground, and directly gate is connected with VI, and here we'll be getting VO. This is very small RD. Okay, we'll do all the namakaran here. Done. So this is your AC equivalent model. AC equivalent model of CD amplifier. Though you all know the formulas of voltage gain, input impedance and output impedance, you have to draw this AC equivalent model such that even though one resistor, source resistor or a load resistor is been added, then things will become very simple to go for the exact analysis with load resistance and source resistance. Let's proceed for first finding of AC analysis, that is voltage gain. voltage gain is VO divided by VI. Okay, as this is CD amplifier, I know the formula. That formula is GM into RS parallel to small rd divided by 1 plus GM RS parallel to small rd. Very simple. As I know that small rd is equal to 50k and RS is equal to 820 ohm, we'll take the parallel combination first and then we'll put this in the formula of voltage gain. This value is 806.7 ohm, less than least resistor, less than 820 ohm. I know the value of GM, so we can easily proceed further for VO upon VI is equal to GM is equal to 2.993 milli multiplied by this value, that is 806.7, divided by 1 plus same value, that is 2.993 milli into 806.7. Let's calculate the first value and then come to me. So the answer is 0.71. VO divided by VI, and that is nothing but voltage gain. So we reach to our first finding, whose value is 0.71 without any unit because voltage to voltage ratio. Let's move further for your output resistance and input resistance. From this equivalent model, it is very clear that if we look from the input side, we will be getting the value of Ri is equal to Rg itself. So there is no calculation in between to calculate the value of input resistance. That is, directly we will be getting the value Rg, which is equal to 1 mega. The value of output resistance has some formula. We have to do calculations for that. So input resistance is straightforward. Ri is equal to Rg is equal to 1 mega ohm. The actual formula for output resistance is Ro is equal to Rs parallel 1 upon Gm if Rd is not present, but here Rd is given, so we have to take again one parallel combination with Rd, right? If you have confusion, you can refer my video, which is nothing but comparative analysis of CG, CD and CS amplifier. So this is the formula with Rd. I know all the values. Let's fatafat calculate the value of parallel combination of Rs 1 upon Gm and Rd, and that is nothing but the value of Ro. Let's check your calc is working or not. Take a short span of time of 2 minutes, pause your screen and then come to me. So the value of output resistance is 236.3 ohm. So this is how we reach to the findings of voltage gain, input impedance and output impedance. In upcoming videos, we will learn how to do high frequency analysis, how to do low frequency analysis with BJT as well as FET. So stay tuned for further videos and like, share and subscribe Ekeeda channel. Thank you so much.